So here's a device known as a radiometer. It's meant to measure the intensity of electromagnetic radiation. So I've seen some demonstrations before, explanations that try to describe the behavior of this radiometer in terms of photon momentum. It turns out that particles of light known as photons, although they don't have mass, they do have momentum. It's not calculated as P equals mv. Photons have no mass, so we can't calculate their momentum as P equals mv. There is a way to calculate it based on the frequency of the light associated with those photons, but that's a topic for another day. The radiometer actually works on thermal expansion of the air inside of here. So I'll show you it anyway. I'm going to turn on this light bulb. It'll get very bright, and we can think of light as waves, but it's just as well to think of light as particles. So one argument goes that the particles of light hit the radiometer, and if you look carefully, you can see that each of the vanes in the radiometer is painted white on one side and black on the other. So just like on a really hot summer day, if you're walking barefoot to the beach, for example, you'll probably go out of your way to walk on the white painted stripes because they reflect light better, they don't absorb it. And if you walk on the black asphalt, your feet are more likely to get scorched because black absorbs. So if you think of the light coming from this bulb as particles in the form of photons, those photons hit and stick to the black, whereas when they hit the white, they hit and bounce off. So there's a greater impulse delivered to the white side of the vanes, and a smaller impulse is delivered to the black side of the vanes. So if these radiometers really worked on photon momentum, we would expect it to spin in this direction. Watch carefully when I turn on the light. Some people call these a light mill as opposed to a windmill, and you'll see why. As long as light shines on it, then it starts to spin. It's as if they're, right? This is similar to the phrase solar wind. There's something like a wind that seems to be coming from this light bulb. But it's not spinning in the direction we would expect if it really did operate on photon momentum. It's spinning quite the opposite direction. What happens is the black side of the vane, because it absorbs the light, warms up faster than the white side, and so there's a greater thermal expansion coming off of the black side than the white side, and so that creates a change in pressure that drives the system in this direction.